couldn't contain my excitement without sharing this video with you. I know for the fact that 80% of you are eagerly waiting for this. This is absolutely magical. Surprisingly, this video is going to be so simple, so quicker, so smoother, and it's definitely going to make a sense. The steps I have taken are experimented and incorporated by me, so it will certainly help you to become confident. These steps are so simple and so powerful. And let's get into today's video that is on conformal mapping. So here are the two problems which are related to bilinear transformations. See here, find the bilinear transformation which maps the points 2, I, minus 2 into the points 1, I, minus I. And next one, find the bilinear transformation which maps the point 0, I, 1 into the points minus 1, 0, 1. So here, the first solution which I am going to give is, so before going into the solution, let me explain you about the formula. So here are the first points, general points, that is Z1, Z2, Z3. And here are the image points W1, W2 and W3 of the general points Z1, Z2, Z3. So here, how to remember this formula? See here. So in order to remember this formula, please add Z on either side. Please add W on either side. See here, first of all, we have to take all the first 4 points Z, Z1, Z2, Z3. See here, so Z, Z1, this is Z2 and Z3, divided by, next time we have to take these 4 points. So this is Z1, Z2, this is Z3, Z. So here, this is how we have to remember this one. This is minus Z1 into Z2 minus Z3, Z1 minus Z2, and this is Z3 minus Z. So here also, first we have to take the first 4 points here, that is W, W1, W2 and W3, divided by, later we have to take these 4 points, that is W1, this is W2, this is W3 and this is W. And see here how to remember this. The formula in the numerator will be W minus W1, W2 minus W3. So here W1 minus W2 and W3 minus W. So this is how we have to remember this bilinear transformation formula. This is so simple if you put. So this is a unique bilinear transformation directly from the textbook. See here, I'll apply this formula for the solution. Find the bilinear transformation which maps the points, that is 2i minus 2 into the points 1i minus 1. So here, so in the solution here, the points here are 2, 1, minus 2. And here the points are 1, I and this is minus I. So here if you consider these points as Z1, so this is Z1, this is Z2 and this is Z3. So here are the points, that is W1, this is W2 and this is W3. See here, so if you take Z on both sides and here W on both sides, so here the formula is also very simple. First thing here is Z minus Z1. So this is Z minus Z1 into Z2 minus Z3, divided by, so here next time we have to take these 4 points, that is Z1 minus Z2, and next one, this is Z3 minus Z. So which is equal to, first of all we have to take the 4 points here, this is W minus W1, this is W2 minus W3, divided by, next time we have to take all these 4 points here, that is W1 minus W2, and here this is W3 minus W. And see, if we substitute all the points here, and this is going to become, see, this is Z minus 2. So this is Z minus 2. And next one is I minus of minus plus 2 divided by, see here, if I start with these two, this is 2 minus I, and next one, this is minus 2 minus Z. Clear? If I substitute all the values here. And next one, this is W minus I. So if you consider all the 4 points here, W minus I, this is I minus of minus plus 1. And later if you consider these 4 points, this is 1 minus I. So this is 1 minus I into this value is minus 1 minus W. So the next step which I am going to take is, I am going to keep these Z terms at one place. This is Z minus 2. In the denominator, if I take minus, this will be Z plus 2. and this value is 2 plus 1, and this is 2 minus 1. Clear? So here in this term also, this is w minus 1. So here this, if I take minus common, this will be w plus 1. So here this is 1 plus I, and this is 1 minus I. Clear? So constant at one place and variables at one place. So I can cancel this minus on both sides. So if I send these constants to other side and see what happens, so this will be z minus 2 by this is z plus 2. So if I send, this will be 2 plus I into this is 1 minus I, and later this is 2 minus I into, if I send to the denominator, so this is 1 plus I, which is equal to w minus I by w plus 1. So now I am going to multiply this one. So this is z minus 2 into, this is 2 ones are 2. If I multiply, this is 2i. If I multiply, this value is I. So this is minus I square value is minus 1 divided by, so this will be z plus 2. If I multiply, this is 2 plus this value is 2i. So this value is minus I, and this value is I square. So this is minus 1. Clear? So this is w minus 1, this is w plus 1. So if you observe this one, this is z minus 2 into. So this is going to become 2 plus 1. The value here is 3. Minus 2i plus I is minus I. By, so this value is z plus 2 into. This is 2i minus I is I, and 2 plus 1 is 3 plus I. Clear? So this is w minus 1. So this is w plus 1. And see here, next I am going to rationalize this one. So in order to rationalize, what we have to do, this is z minus 2 by this is z plus 2. And next one, this is w minus 3 minus I, this is 3 plus I. So if I want to rationalize, see here what I'll do. So this is 3 minus I. So this is 3 minus I. So I'll be multiplying with 3 minus I into 3 minus I. So which is equal to, this is w minus 1. This is w plus 1. And the next step here will be, so see here, this is z minus 2 and this is z plus 2. So this is 3 minus 1 and this is 3 minus 1. So this is 3 minus 1 whole square. A plus b into a minus b is a square minus this value is b square. So which is equal to w minus 1 and this is w plus 1. So this is w minus 1 and this is w plus 1. And see here, so this is going to become, this is z minus 2 and a minus b whole square is nothing but a square plus, so this value is b square minus 2ab divided by, so this value is z plus 2, so 3 square value is 9 minus I square value is minus 1, this value is plus 1. So here this is w minus 1, so this is w plus 1. So clearly I square value is nothing but, so what is our I square value? I square value is nothing but minus 1. So if I substitute minus 1 here, then this will be z minus 2, this is 9 minus 1 minus 6i divided by, this is z plus 2 and this value is 10. So this is w minus 1 and this is w plus 1. See here, slowly each and every step is very clear here. 9 minus 1 is 8 minus 6i divided by, this is z plus 1 into 10, which is equal to w minus 1 and this is w plus 1. So I can take 2 common and cancel. So if I take 2 common and cancel, see here, this will be 4 minus 3i. So here this is z plus 2. So this will be 2 into 5. So this is w minus 1 and this is w plus 1. If I cancel these and see what happens, now I am going to multiply these two. So this is z minus 2 into this is 4 minus 3i and this is 5 times of this is z plus 2. So which is equal to w minus 1 and this is w plus 1. So if I multiply, see what happens here. So if I multiply or applying component on dividend method. So if I apply, so here now if I apply componendo and dividendo. So what is this component of dividend for a by b fraction? So we have to make an addition for one time and we have to make a subtraction for one time. So this is the fraction a by b. So we have to add up these two for once in the numerator and we have to subtract in the denominator. And so this is going to be, this is z minus 2 into this is 4 minus 3i plus, and this is 5 times of this is z plus 2 divided by, so here this is z minus 2 into 4 minus 3i minus 5 times of this is z plus 2, and here it will be w minus 1 plus w plus 1, and see here this is w minus 1, this is minus w minus 1. Clear? Now if I multiply, this will be 4z, and if I multiply, this will be minus 3zi. So if I multiply, this will be minus 8. This is minus of minus plus 6i. And see, if I multiply, this will be 5z plus 10 divided by. So if I multiply, this is going to become 4z minus 3zi. This is minus 8. And this is minus of minus plus 6i, and this is minus 5z, and this is minus 10. So if I cancel these two, this will be 2w. So if I cancel these two, this will be minus 2. Clear? And now see here what I am going to do. So this is so important. So here is 4z and here is 5z. Here is 4z and here is minus 5z. And see, I am going to add up these two. This will be 9z. And see, the next thing here, what I am going to do is minus 3zi. So this will be minus 3zi, and here this is plus 6i. So here this is plus 6i, and here if you observe, this is minus 8 and this is plus 10. So which I can write as 2 divided by, see here, this is going to become minus z minus 3zi plus again 6i. So here if you observe, this is minus 8 minus 10. So this is going to become minus 18. So if I cancel, so this is going to become minus w. Clear? And now see here, from this, if I take 3z common, so from the numerator, if I take 3z common, so this is going to become 3 minus I, and see here, from these two, if I take 2 common, this is going to become 3i plus 1 divided by. So in the denominator, if I take minus z common, so this will be 1 minus plus, this is 3i, and if I take 6 common, this will be I minus 3, which is equal to minus w. So this is minus w. Now if I solve this one, see what happens. So if I solve this one, so this is 3z, so this is 3 minus I, and again if I take I common from this, if I take I common, so this is going to become 3. If I take I common, so this is going to become minus I. So if I multiply, so this will be 6i, and this is going to become minus I square is minus 1 and plus 1. So this is balanced. And see here, from this also, if I take minus zi, so if I take minus I common, so I want 3 here, this is minus I. So here if I take minus common, minus from this, so this will be 3 minus I, this is minus w. And next thing here is, so here if you observe this one, this is 3 minus I, this is 3 minus I, this is 3 minus I, and this is 3 minus I. So if I take 3 minus I common from the numerator, this will be 3z plus 2i. So if I take 3 minus I common, this will be minus zi minus 6, so which is equal to minus w. Now I can easily cancel this one. So after cancelling, if I take minus common, see here, so this is minus w is equal to, this is 3z plus 2i. So if I take minus common, so this will be zi plus 6. So now I can easily cancel and see here, and therefore we got our w value. So this is so important here. So this is 3z plus 2i, and this is zi plus 6. So this will be our w value, and this is how we have to solve. And see here, these are all the few steps. So here the formula is also very easy to remember after substituting and rationalizing here and applying component or dividend method. So we'll be getting Each and every step is very clearly explained here, applying component or dividend or method. So we need the W value, and so this is how we have to attain the W value using the bilinear transformation formula. And the next question here is find the bilinear transformation which maps the points. So here are the points, that is 0. So this is 0, I1, and this is minus 1, 0, minus 1 0, and this is 1. So here are the points, that is z1, z2 and z3, and here are the points w1, this is w2 and this is w3. So here, in order to remember, so keep add z on both sides and w on both sides. First of all, we have to take the 3 points here. So here, after taking 4 points here, first 4 points, that is z minus z1. So here this value will be z2 minus z3 divided by, later we have to take the second 4 points, and this will be z1 minus z2. So this is z1 minus z2, and next one, this is z3 minus z. And here also, first we have to take the 4 points here, w minus w1, and next one, this is w2 minus w3 divided by, later we have to take the 4 points here, that is w1 minus w2, and next one w3 minus w. And now if I substitute all the values here, so all the values here, this will be z minus 0. So this is a z minus 0, and this is I minus 1. And here next 4 points, that is 0 minus I, and this is 1 minus z. So here also, that is w minus of minus plus 1, and this is 0 minus 1. And here the 4 points, that is minus 1 minus 0, and this is 1 minus w. And now we have to arrange z at one place and w at one place. So here z minus 0 is z. So here this is I minus 1, and here z at one place. If I take minus common, this will be z minus 1, and this is minus I. And here if you see, this is w plus 1 at one place. So here if I take minus, this is w minus 1. So this value is minus 1 and this value is minus 1. If I cancel this one, so even if I cancel this term, then what happens here? So this will be zi minus z. So if I send minus to the numerator, so here this will be zi minus z, and this is minus zi minus, so this is minus of minus plus I. So this value is nothing but w plus 1, and this is w minus 1. So what we have to do? So we have to apply componendo and dividendo method by applying, see here, after applying componendo and dividendo method. So after applying componendo and dividendo method, so this is going to become, this is zi minus z. So this is minus zi plus I divided by, so this value is zi minus z plus zi minus I, which is equal to, this is w plus 1 plus w minus 1, and so this is w plus 1, this is minus w plus 1. So here if you observe, we can cancel these two. And later, see here which one we can cancel, minus 1 and plus 1, this is minus w and plus w. And see if you observe, so this is going to become minus z plus I, and here it is minus z plus, this value is 2zi, this value is 2zi, and this is minus I. So this is minus I, or this value is 1. See, let me see. So this is zi minus z minus zi minus I. So this is going to become minus I. So this is 2w by 2. So if I cancel, the value here is w here. And now if I take minus common here, so if I multiply with I here, so here in order to balance, so if I multiply with I in the numerator as well as the denominator, so this is going to become, see here, minus zi, I squared, this is minus 1, divided by, if I multiply, so this will be minus zi, so this is minus 2z, and this is I square minus 1, so this is minus of minus, this value is plus 1, so which is equal to w. Now if I take minus common in the numerator, so this will be zi plus 1. So if I take minus common, so this will be zi minus 2z, and this is minus 1 is equal to w. So now if I cancel minus on both sides, and therefore our w value is equal to, see here, our w value is equal to, this is zi plus 1 by this value is zi plus 2z, sorry, this is minus 2z. So if I take minus common, see here is a mistake. So if I take minus common from these two, so this is going to become plus. See here, this is going to become minus. So here, this will be, if I take minus common, so this is plus 2 plus 2z, this is minus 1. So this is the formula here, and therefore our final answer, I am adjusting here, w is equal to, this is zi plus 1. So if I take z common, this will be 2 plus I, so this will be 2 plus I, and this is minus 1. So this is how we have to solve. This is also so simple here. So the formula is also so simple. If I substitute all the values here, and if I bring z at one place and w at one place and constants at one place, and if I manage and applying competent or dividend method, and after balancing with I, rationalizing, and see here, our final answer will be this one. Thank you so much for watching. So here, this is the way you have to do for any problem. So I'll be posting few more problems which are very important, repeatedly asked questions. So here I'm uploading each and every video in the playlist. So playlist is very, very precious, because each and every problem from the textbook is given solution, and the video is posted in the playlist. So if you really like, what to do, please raise your thumb, pass it on to your friends, and subscribe to this channel, and stay connected. And my next video will be uploading very, very soon. Have a look at those, and definitely you can score more, and your solving skills also will improve drastically. And thank you so much for watching and staying till the end.